Yeah, I agree that that is definitely calcite. Oh, hello. I didn't see you come in. And welcome back to class. Sorry about that. I was in a little bit of a thought process on set. We are going to be talking about a concept that earth scientists use to identify and make sure that this mineral specimen is indeed calcite. So I want to welcome you to week 4 in the class, where we are going to venture into the dynamic geosphere. You see, the geosphere is part of our Earth system's theory, where it encompasses all of the rock and mineral forming processes found on our planet. And it gives Earth scientists, those that study this type of science, a wonderful outlook on how has our Earth changed over time since its early formation. Rocks and even minerals such as these tell a wonderful tale about what is going on our planet. So let's actually go and take a look at the concept behind what we're going to cover this week. Now, in many traditional earth science classes, they open up with a identification of minerals where there are a select set of physical properties each mineral has. Each of these physical properties are distinct for that mineral. You can think of it like when you go to a doctor and you're not feeling well. You feel like you have a cold. Well, the doctor will run a series of tests, use specific characteristics that are being exhibited to determine, do you have a cold or do you have something more like a really bad flu? Well, we can do the same thing with rocks and minerals. And we are going to start off with minerals and work on understanding that concept. We can actually take the physical properties, such as the luster of a mineral. Is it metallic or does it look non-metallic, almost earthy, like this piece of calcite? We can take a look at the hardness. Does it scratch a glass streak plate or does it not? Minerals can be ranked using that characteristic. We can even take a look at very special properties, such as right here, I have some hydrochloric acid. Now, we learned in the previous week that chemical reactions do occur. One such reaction is taking hydrochloric acid and it strongly reacts to calcium carbonate, which is one of the chemical elements, calcium, found in calcite. So we can even drop a little bit and on this specimen and watch it fizz. Every mineral among the 4,000 or more minerals that naturally occur on our planet have a very distinct set of properties that are unique to them. And so our goal this week is for you to go out and investigate a conceptual model, which are these physical properties, and how earth scientists think about identifying minerals. And then you are going to combine it with a physical representation. But seeing this as a virtual class, I help you out with the virtual representation of that model by showing you examples of different minerals. In fact, I actually have a box of minerals that I've collected over the years and have taken a lot of really good high-resolution pictures for you and have identified a lot of the common properties that minerals have. So that way you have a way to connect the conceptual, which is how we think about the minerals, and the identification. We are also going to make use of databases. When many students in Intro to Earth Science courses, they will tend to purchase identification guides, such as this Simon and Schuster's Guide to Rocks and Minerals, and use that as a way to identify their samples in their course. But technology has greatly changed on how we communicate science. And I'm going to show you a few mineral databases that are crowd sourced, meaning or scientists such as myself can, and even you can contribute to the body of knowledge of what certain minerals are defined as and where can you find them. And so that's going to be our lab. And then in lecture, we are going to take a look at some of the material in the book on the conceptual level and talk about really what is a mineral. Because minerals, again, they tell a wonderful story about our dynamic Earth. For example, when I look at this piece of limestone, we can take a look at the calcite into it. So this tells us that calcite contributes to the formation of limestone, but we can also look at some of that microtexture. I'm actually seeing from the backside right here, I see little pieces of seashells, and even right here, we see a massive scallop. So this tells us that the calcite that contributes to the formation of this limestone formed in a aquatic environment. And so that actually gives us a really good insight on really why minerals are important for us to study, because it lays that foundational groundwork for next week's topic when we talk about the three major rocks, such as sedimentary rocks, metamorphic rocks, and igneous rocks, which will have their own system of identification, just like what we're going to cover this week. So this week will be practice for next week in our conceptual thinking. So if you have any questions, feel free to reach out. You can get a hold of me through email, in person, or on Zoom. Thank you and have a lovely day on our planet Earth, and keep learning, friends. Cheers.
You know who made it.